In this part, we talk about the maximum and minimum in trigonometric expressions. Before we look at trigonometric expressions, there is one word about inequalities. So I'll show you some examples for various situations in inequalities. If x is lying between 5 and 4, alright, what do you think about x squared? If x is lying between 5 and 4, then x squared will be lying between the square of 5 and square of 16, right? Now that's good, no problem with it. Alright, but what if x is lying between 1 and minus 2? What does that mean? Alright, that means x squared is lying between the square of 1 and the square of minus 2, that is 4, right? Now it looks funny. How can x squared be smaller than 1 and yet at the same time it is greater than 4? So it does not look right. Alright, and furthermore, if I have another example, what if x is lying between 3 and minus 1, right? So how about x squared? So once again, you take the square. X squared will be lying between the 3 square is 9 or minus 1 square is 1, alright? Now, but the problem is it looks fine, but in fact it is wrong. Alright, it is wrong. We cannot do this. Now, the reason being, the correct one shall be when x is lying between a positive and a negative number, is lying between 1 and minus 2, the square can go up as large as 4, but it can also be 0. X can be 0. If x is 0, the square is also 0. So this one is wrong. The correct one shall be x squared is lying between 4, but is also greater than equals to 0, right? That is one, major idea to know about inequalities. And likewise, for the third example, if x is lying between 3 and minus 1, x squared shall be smaller than 9, but at the same time it is greater than or equal to 0. These are the correct versions, alright? What I marked in red, those are wrong. So when you take the squares, be sure that there are some of the concerns in positive and negative number. Right. So that is also applicable to the reciprocals, to 1 over x, right? So let me give you a brief summary on how these positive and negative affect squaring and reciprocal. If a is greater than b is greater than 0, right? How do you compare a squared and b squared? How do you compare 1 over a and 1 over b? If a is greater than 0, but b is less than 0, how do you compare a squared and b squared? How do you compare 1 over a and 1 over b? Finally, what if both of them they are negative? A is smaller than 0, but b is smaller than a. So how do you compare a squared and b squared? How do you compare 1 over a and 1 over b? Alright, so here there is an inequality sign you have to fill in. Alright, there is an inequality sign you have to fill in. Now you may pause the video for a while and think about which inequality sign shall we put in between a and b for various conditions, plus and minus between a and b. Okay, so did you get the answer? Can you think about the inequality sign in this 6 different scenarios? Okay, let me tell you the answer. If a, b, they are both positive and a is greater than b, then it is the easier case. We have a squared greater than b squared. For positive numbers, the greater it is, the greater the square it is. And on the other hand, the greater the number, the smaller should be the reciprocal, right? Say 1 over 10 is less than 1 over 1, alright? So we have the first one. Now for the second one, if a, b, 1 is positive, a is positive, b is negative, alright? Now for the reciprocal, 1 over a will therefore be positive. 1 over b will therefore be negative. Never mind the value. 1 over b is always positive. So 1 over b is always negative, sorry. So 1 over a is a positive number. A positive number is always greater than a negative number, right? Never mind the value. However, between a squared and b squared, there's no way to tell. Alright, there's no way to tell. We have, if you look at the previous examples, alright, 1 is greater than minus 2, but when you take the square of 1 is smaller than the square of minus 2. 3 is greater than minus 1, but 3 squared is greater than the square of minus 1, so there's no way to tell. Now, what if they are both negative? Alright, A is the next negative number, B is the more negative number. Alright, in that case, the square is reversed. B squared will be greater than A squared. So are the reciprocals. 1 over B will be greater than 1 over A. Alright. Well, it seems complicated, but you don't really have to memorize it. But I want you to know that when you take the square and you take the reciprocal across plus and minus, you have to pay attention to some of the features. Alright. So now, with these ideas in inequalities, we can start looking into the maximum and minimum value of the trigonometric function. We make use of these 4 different building blocks for trigonometric maximum minimum. Alright, we have if you refer to the graph, right, we have sine x is always between 1 and minus 1. So we have sine x is less than equals to 1 and greater than equals to minus 1. Sine x is always between 1 and minus 1. So is cosine x, right? Cosine x is always between 1 and minus 1. However, if you take the square, sine square x will be less than 1 but greater than equals to 0. It can be 0. It cannot be negative. Right, cosine square theta is also lying between 1 and 0. Now, we don't have inequality for tangent because tangent theta can be, as large as possible, or it can be as small as possible. Alright, so now we use these 4 building blocks to consider all the maximum minimum value of the trigonometric expressions. So I'll show you 5 examples. Alright, so let's start with the first one. Find the maximum minimum in 3 plus sine x. Alright, this is an easier one. Now we start with a building block. We have sine x as the building block. Alright, on one hand is less than 1. On the other hand is greater than minus 1. Alright, so we just simply add 3 to all the 3 sides. Alright, you cannot just add 3 on one side, on one pair. You cannot just add 3 here. That would be wrong. You have to add a triplet, a trio of 3 on the left hand side, the middle part, and the right hand side. Alright, so when you add 3, you have the expression 3 plus sine x, and that is between 4 and 2. So naturally, this is the maximum value. The maximum value will be 4, right? And the minimum value will be 2. So the maximum is 4. The minimum is 2, alright? So this is how we set up maximum and minimum quantities in a trigonometric expression. Now let's take a look at the second example. We have some reciprocals. How about 1 over 4 minus twice sine x? Alright, what is the maximum and what is the minimum value? Alright, so once again we start the building block with sine x. Alright, so sine x is lying between 1 and minus 1. Alright, we multiply minus 2 to all 3 of them. Alright, so it becomes minus 2, but when you multiply to a negative number, right, you have to switch the inequality sign. Alright, so 1 is multiplied to minus 2. Every one of them is multiplied to minus 2. Multiply to minus 2, multiply to minus 2. But when you multiply a negative number, you have to switch the inequality sign. Alright, so we have this. And then you can add 4 to every one of them. Alright, add 4. Add 4. So you have 4 minus twice sine x is greater than equals to 2, but less than equals to 6. And then you can take the reciprocal. Both 2 and 6, they are positive number, fortunately, so that you can take the reciprocal. Remember, when you take the reciprocal and they are positive number, you should swap the inequality sign again. Alright, the larger the number, the smaller the reciprocal is. Alright, so you should swap. You take 1 over, alright? You take 1 over. You take 1 over. But then you also have to swap the direction of the inequality. So this is it. We construct the expression 1 over 4 minus 2 sine x from the sine x between 1 and minus 1. So we know this will be the maximum value. This is the minimum value. So the maximum is 1 over 2. The minimum is 1 over 6. Alright, this is part 1. We'll have 3 more examples in part 2.